Hi everybody! For today's notes, we are going to review another topic. We're going to review solving quadratic equations. And there are several ways to solve quadratic equations, so we'll talk about some of them this time, and then next time we'll talk about the rest. So we're going to split this into part 1 and part 2, but there's only one video today, part 1. And this is notes number 5, I do believe. So today we're going to look at 3 methods for solving quadratic equations. And the first method is called solve by factoring, and it uses what we know as the zero product property. Sometimes the zero product property has a slightly different name, but the meaning is something like this. If A times B equals 0, then A equals 0 or B equals 0. And in math, when you say or, it could be one or the other or both. So I'll just make it clear. A equals 0 or B equals 0 or both. So what that's telling you is if you're multiplying two things and you end up with 0, then one or the other had to be 0. So hopefully that is just going to make common sense to us. So if we use that property to solve an equation, that means we're going to change the equation into some kind of factored form and set each factor equal to 0. So let's take a look at number 1. We have the quadratic equation 10x squared plus x minus 2 equals 0. And we can factor the left side of the equation. It factors into 5x minus 2 times 2x plus 1. Notice that we have a 0 on the right side of the equation, and you have to have a 0 on one side of the equation if you're going to use this property. You can't have a times b equals 1, or a times b equals 2, or a times b equals 3. The property only works if it's a times b equals 0. So once we have it factored, we set each factor equal to 0. So 5x minus 2 equals 0, or 2x plus 1 equals 0. And then we solve each of these. So for the first one, add 2 to both sides, divide by 5, and we have x equals 2/5. And then for the second one, subtract 1 from both sides and divide by 2, and we have x equals negative 1/2. So x equals 2/5 or x equals negative 1/2. So we have 2 answers. Now when you're looking up your answers in the back of the book, there's a possibility that they're going to use set notation. So they might show the answer like this. X is an element of the set containing negative 1/2 and 2/5. You don't have to write your answer that way, but I just want you to recognize that it's equivalent to what we wrote another way. Okay, let's take a look at problem number 2. Again, we're going to solve by factoring if possible. Of course, we know that not every quadratic expression is factorable, so not every quadratic equation can be solved this way. So what we can do first is get all the terms over to one side so that we have a 0. So let's subtract 21x from both sides, and we have 6x squared minus 21x plus 9 equals 0. Notice that all the coefficients on the left side are divisible by 3, so if we go ahead and divide both sides of the equation by 3, we get 2x squared minus 7x plus 3 equals 0, and that's just going to make it a lot easier to factor. It will still work out to give us the same answers if we don't divide the equation by 3, but it'll be a lot harder to solve or to factor if we don't divide by 3. So now that we have this, turns out that it is factorable, and it factors into 2x minus 1 times x minus 3. Okay, and then from here we set each factor equal to 0. So we have 2x minus 1 equals 0, or x minus 3 equals 0. And let's solve each of these. Add 1 to both sides, divide by 2, we get x equals 1/2. And for the other one, add 3 to both sides, we get x equals 3. So x equals 1/2 or x equals 3. And we could use set notation and just put them in set braces if we want to. Okay, so that's the process of solving by factoring. Method number 2 is solve by square rooting. So when you take a look at problem number 3, you'll notice it is a quadratic equation, and there's an x squared term, but there's no x term. And because there's no x term, we can use a slightly different method on this one. We can isolate the x squared by subtracting 2 from both sides of the equation, so we have x squared equals 7. And then we can square root both sides of the equation. And remember, when you square root, you always have to put plus or minus. So x equals plus or minus square root 7. Now, we like exact answers in here. There's no need for this problem for us to pull out a calculator and find an approximate answer. So just keep it as a radical. And if the radical needed to be simplified, then we would do that. So we have x equals plus or minus square root 7. Okay, number 4 is a little bit different, but kind of its shell is the same as number 3 because we have something squared equals a number. So if you look back at number 3, when we got to this point, right before we square rooted, it was basically something squared equals something. And when you have something squared equals something, you can go ahead and square root both sides. All right, so that's what we have going on in number 4. We have something squared equals something. So we can go ahead and square root both sides. So that will give us x minus 1 equals plus or minus square root of negative 16. Now let's go ahead and simplify the square root of negative 16. Remember, anytime you see the square root of a negative, you know it's an imaginary number, and the first step is to change it to the notation using I. So we have plus or minus I times square root 16, and square root 16 is 4. So we have x minus 1 equals plus or minus 4i. And then the last step to get x by itself is to add 1 to both sides. So x equals 1 plus or minus 4i. Okay, let's move on to method number 3. So method number 3 is to solve by completing the square. And completing the square is a process which allows us to take any quadratic equation and get it into the form that we saw for problem number 4. And if you have your problem in this form, you can square root both sides. So what we're going to do is look at this problem number 4 and imagine what it might have been before it looked like this. So kind of working backwards. So before it looked like this, it's possible that it looked like this. X minus 1 times x minus 1 equals negative 16. And before it looked like that, it's possible that the x minus 1 times x minus 1 was actually multiplied out, and it would look like this. X squared minus 2x plus 1 equals negative 16. Now, if you remember one of the things we talked about in our factoring lesson, x squared minus 2x plus 1 is a perfect trinomial square, or perfect square trinomial. There's a lot of different ways to say it. It factors into the same factor twice. So when you look back up, it had x minus 1 and x minus 1 as its factors. Okay, so maybe before the equation looked like this, maybe it looked like this. X squared minus 2x plus 17 equals 0. You see what I just did was I added 16 to both sides of the equation to get this. So if you started with this equation right here, then you could solve it by completing the square by just going through the process of working your way to a perfect trinomial square, to the factors, and then square root both sides. So that's what we're going to do on the next problem. And this is the process that we call completing the square, or CTS, when you're texting. So here's number 5. We have x squared plus 10x minus 20 equals 0. Start by asking yourself, is x squared plus 10x minus 20 a perfect trinomial square? Well, it's not, because 20 is not a perfect square. There's another reason why it's not, but because we see that reason, we can just stop right there. It's not a perfect trinomial square. So then we need to make a perfect trinomial square for our completing the square process. So here's how I like to do it. I keep the x squared and the plus 10x, and then we're going to complete the square. So I don't know what number I'm going to add, but I'm just going to leave a blank for it. I'm going to add the 20 to both sides of the equation to get it over to the right, because I just don't want it in the way on the left. Now, whatever number I add to the left of the equation, I also have to add to the right of the equation to keep it balanced. So now our goal is to figure out how to make this a perfect trinomial square. Let's think about what we would get when we factor it. It's going to have to be x plus 5 quantity squared, because in order for the outsides and insides to add to 10x, they're going to have to be 5x and 5x. So if that's the case, then that tells us that we're going to need a 25 right here, because if you have x plus 5 times x plus 5, see, your inside is 5x and your outside is 5x, that's where the 10x comes from, but then when you multiply the last, it would be 5 times 5, which is 25. So the number we add is 25. Now your shortcut for that, for next time you do one, is to take this number here, cut it in half, and then square it. So half of 10 is 5, square it, you get 25. Now remember, since we add 25 to the left side, we also add 25 to the right side of the equation to keep it balanced. Okay, so let's keep going. So now that we know what to add to complete the square, we write the left side in its factored form, x plus 5 quantity squared, and then on the right side we can add 20 and 25 and we get 45. Okay, so now we have the right form that we can square root both sides. We have something squared equals something. So square root and you get x plus 5 equals plus or minus the square root of 45. And we can simplify the square root of 45. That would be 3 square root 5. And then to get x by itself, we subtract 5 from both sides. So x equals negative 5 plus or minus 3 square root 5. Those are the two answers. Okay, let's try it on number 6, but number 6 is a little bit more complicated because of the 9. So when you complete the square, if you look back at number 5, notice that the coefficient was 1 on the x squared term. That's really important. We need a 1 there. So what we're going to have to do on number 6 is divide the whole equation by 9. So that gives us x squared minus 12/9 x plus 1 equals 0. And let's write 12/9 as 4/3. Okay, so remember what we did last time. We left the x squared and the minus 4/3 x, and then we're going to figure out what number to add to complete the square. And I'm going to subtract 1 to get it over to the other side, and then whatever number I add to the left, I add to the right. So now it's time to figure out what number we add to complete the square. So we take half of this number, half of negative 4/3 is 2/3, and we square it, and that would be 4/9. So 4/9 completes the square. So add 4/9 to the left and add 4/9 to the right. So now we have our perfect trinomial square, and we need to write it in its factored form. So it would be x minus 2/3 quantity squared. X minus 2/3 times x minus 2/3, that's how we're going to get the 4/9 at the end. Okay, then on the other side of the equation, when you add negative 1 and 4/9 together, you get negative 5/9. So now that we have our equation looking like this, we are ready to square root. So square root both sides, you get x minus 2/3 equals plus or minus the square root of negative 5/9. And because we have the square root of a negative, we need to change it to the notation with I in it. So x minus 2/3 equals plus or minus I square root 5 over 3. And then finally, to get x by itself, we're going to add 2/3 to both sides. So we have 2/3 plus or minus I square root 5 over 3. Okay, what we're going to do is a couple more problems to practice completing the square. So what I would recommend is you pause the video, try it yourself, and then resume, and you can see if what you did and what I did are the same. So number 7, x squared minus 5x minus 3 equals 0. So what I'm going to do is add 3 to both sides, and I'm going to leave a space to complete the square. Now to figure out what number goes in the box, I take half of negative 5, so that would be negative 5/2. By the way, always use fractions, not decimals, because it is so much easier to square fractions and to square root fractions. You don't want a decimal there. So half of that would be negative 5/2, and then we square it and we get 25/4. So 25/4 completes the square. Okay, so now we write this in its factored form, and we have x minus 5/2 quantity squared equals, and then when it's time to add our 3 and our 25/4, I believe we end up with 37/4. And now we can square root both sides. So we have x minus 5/2 equals plus or minus the square root of 37/4. I'm going to break that up into square root 37 over square root 4 because square root 4 is just 2. And then finally, to get x by itself, we add 5/2 to both sides. So x equals 5/2 plus or minus square root 37 over 2. Now there is nothing wrong with writing your answer like this, and it's possible that you'll see your answer like this if you look it up in the back of the book. 5 plus or minus square root 37 all over 2. That's fine too. Okay, let's look at number 8. Notice that number 8 is divisible by 2, so let's do that. X squared plus x plus 3 equals 0. I'm going to subtract 3 from both sides just to get it out of the way, and I'm going to leave that space for the number that completes the square. Now to figure out what completes the square, in front of the x we have an invisible 1. So we take half of that number and square it. So half of 1 is 1/2. Square it, we get 1/4. So 1/4 is the number we add to complete the square. So now we write the left side in its factored form, and we have x plus 1/2 quantity squared. And then when we add the numbers on the right side together, we get negative 11/4. The next step is to square root. So we have x plus 1/2 equals plus or minus the square root of negative 11 over the square root of 4. So that would just be over 2. And then I'm going to do, excuse me, a couple things at once. I'm going to subtract the 1/2 from both sides to isolate x. And I'm also going to change the square root of negative 11 and write it as I square root 11. So our answers are negative 1/2 plus or minus I square root 11 over 2. Okay. So for today, your assignment is to work on page 119, numbers 13 through 39, odd. These are all the different methods we practiced today: factoring, square rooting, and completing the square. Remember that to submit your homework means to submit pictures of the notes, to submit pictures of the assignment showing your work, and to show that you've checked your answers and made corrections. And of course, if you are not able to make corrections because you have questions, then you should plan to ask me your questions during class time or some other time. Okay, thank you, everybody.